Section 5.5, Trigonometric Equations, Part 1 of the notes. In this section, we are going to solve equations that have trigonometric expressions in them. So we're going to use all of our solving techniques like moving something over by doing the opposite sign, whether it's adding, subtracting, or multiplying, dividing. Or we may even need to factor, where we figure out what multiplies to AC adds to B, and then factor in order to solve a quadratic equation. Example 1, we're going to solve this equation on the interval from 0 to 2 pi. So specifying the interval here is really important. So since I've specified my interval 0 to 2 pi, I'm just going to get my answers off of the unit circle. I will show you though at the end, in case the problem doesn't specify an interval 0 to 2 pi, I will show you how to give an answer for the interval of all real numbers. So first of all, we're going to take our equation and we're going to isolate the trig function. So I'm going to solve for sine of x. First thing I do is I subtract over the 3 sine of x. And then I'll divide by 2. And at this point, I have isolated the trig function on one side. For the second step, I'm going to solve for the variable. So I'm going to see what x could be equal to. First of all, let's note that this is sine of x equals a positive value. So my answer or answers are going to lie in quadrants 1 or 2 because that's where sine is positive. And the question I'm asking in order to solve this is where on my unit circle is my y coordinate equal to square root 3 over 2? Well, that would be at pi over 3 and 2 pi over 3. Again, this is on the interval from 0 to 2 pi. If the problem didn't specify that certain interval, then my answers would look a little bit different. I would take pi over 3 and I would add on 2 in pi. Pretty much that means my answer is at pi over 3, or I could go a whole nother round on the unit circle, or a whole nother. So n is just for any number, okay? So we could plug 5 in there, and that would be pi over 3, and then 5 more times around the circle. Remember, those are all going to be coterminal angles. Example 2, solving a trigonometric equation in quadratic form. So we see in our example here, 4 cosine squared of x minus 3 equals 0, that we have a quadratic going on. So since I just have one squared term and I don't have another cosine term in my equation, I'm going to end up solving for that cosine squared of x and then taking the square root of both sides. So we add the 3 over, divide by 4, and then we square root both sides. Anytime we take a square root, we need to put a plus minus in our answer. So we have cosine of x equals plus minus square root 32. We're going to have an answer from each of the quadrants this time because we have a positive and a negative square root 32. So we're looking in all 4 quadrants to find out where x is equal to either a positive square root 3 over 2 or a negative square root 3 over 2. We find that happening at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. This problem again specifies the interval 0 to 2 pi. If it hadn't specified that interval, then I would just be adding pi in to pi over 6 and 5 pi over 6, and that would cover all of my possible answers. Example 3, again we have a quadratic here, but this time we're going to have to end up factoring because I have a sine squared x term and a sine of x term. Start by moving the 1 over. And then we need to set our x up, what multiplies to AC and adds to B. We're going to factor by grouping, so I'm rewriting that middle term. Now I'm going to factor by grouping, so I've drawn my line in the middle. I'm going to pull a GCF out of the first 2 and a GCF out of the second 2. Then I'm going to rewrite it. 2 sine of x minus 1 times sine of x plus 1. My next step when factoring is going to be to set each of these factors equal to 0 and solve them. So now I'm looking on my unit circle for where sine of x is equal to 1/2. So looking at where y is positive and equal to 1/2. And also where y is equal to -1. So those are my answers on the interval from 0 to 2 pi. If the problem didn't specify 0 to 2 pi, then I would be adding 2n pi to each of those answers.